Hi, hello students. Welcome to Indian Tech Guru for you. In this video, let us learn about Hamiltonian cycles problem using backtracking approach. First of all, let us see what is meant by Hamiltonian cycles. So, Hamiltonian cycle is nothing but starting from a vertex, visit all the vertices exactly once, and return back to the starting vertex. For example, if you consider this particular graph, which is an undirected graph, we may start from any vertex. Assume that we are starting from vertex 1, then we have to visit all the remaining vertices exactly once and come back to vertex 1. For example, we may start from vertex 1 and from 1 to 2, 2 to 3, 3 to 4, 4 to 5, and 5 to 1. So then this will become a Hamiltonian cycle. So what is the order? 1 to 2, 2 to 3, 3 to 4, 4 to 5, and then 5 to 1. We have started from vertex 1 and reached to vertex 1, and we have visited each vertex exactly once. That is very, very important. You should not visit a particular vertex more than once. You should visit exactly once and then come back to the starting vertex from where you started. And if you observe the graph, there will not be any single Hamiltonian cycle. So generally, there will be more than one Hamiltonian cycle. If you observe, for example, we may once again start from vertex number one. However, from 1 to we may go to vertex number 3, and then from 3 to 2, and then from 2 to 4, 4 to 5, and 5 to 1. So this is also one of the other Hamiltonian cycle we can produce using the given graph. However, if you assume that I am starting from vertex 2, then a cycle will be formed from 2 to 3, 3 to 4, 4 to 5, 5 to 1, and 1 to 2. So if you start from 2, 2 to 3, 3 to 4, 4 to 5, and 5 to 1, and then 1 to 2. So however, if you observe, this particular cycle is same as the first cycle. So here we have started from vertex 1, but here we are starting from vertex 2. You may observe here 2 to 3, 3 to 4, 4 to 5, 5 to 1, and 1 to 2. So these two are same Hamiltonian cycles. So that is why we should avoid the duplicates. If you start from a particular vertex and if you start from another vertex, we may get the same Hamiltonian cycle. So that's why uh, let us have a restriction that we always start with vertex number 1. We always start from vertex number 1. So this is a simple restriction we are going to apply so that no duplicate cycles will be produced. So now let me start solving this problem using the backtracking approach. So let me have some space here. Before actually solving the problem, so we need to draw the adjacency matrix for the given graph. So we already know what is meant by adjacency matrix. When there is an edge between two vertices from vertex 1 to vertex 2, then the value is 1. If there is no edge, then the value will be 0. So like this, I have filled all the values of the adjacency matrix for this particular given graph. So to solve the Hamiltonian cycles problem and find out the Hamiltonian cycles, we need to remember 3 points. The first point is the next vertex must not be a duplicate vertex. So that is if the current vertex is 1, then the next vertex must not be 1. And it must not be any of the previous vertices also. So that is, we should not consider any duplicate vertex, as the definition says that we need to visit the vertex exactly once. We should not visit more than once. That means that there should not be any duplicate values. so which are already considered. Next, the second point is there must be an edge between the current and the next vertex. For example, if you are moving from vertex number 2 to vertex number 3, then there must be an edge between vertex number 2 to 3. So then only we can actually move the current location to the next vertex. And point number 3 is there must be an edge between last and the first vertex. So after traversing all the vertices, there must be an edge between the last vertex and the first vertex. Then only a cycle will be formed. For example, starting from vertex 1, if you visited vertex number 2, 3, 4, and 5, but have not returned to vertex number 1, then there will not be any cycle. So to make a cycle, definitely the starting vertex and the ending vertex must be same. So that's why there must be an edge between the last vertex and the first vertex. So these are the rules we should follow. So as usual, we are going to consider the solution matrix, solution array as xi. So here, because there are 5 vertices, so let me consider the 5 locations available in xi. So to solve this problem, as usual, in case of the backtracking, we'll be using the state space tree. So let me solve this problem. First of all, let me assume that I'm starting from vertex 1. So from starting from vertex 1, I should not consider once again vertex 1, because the first point says that the next vertex must not be a duplicate one. So I shall take vertex number 2 in the order. So the first value will be vertex number 1. The second value, I am taking it as 2, vertex number 2. And whenever I am passing the current vertex from vertex number 1 to vertex number 2, I need to check whether there is an edge between the current vertex and the next vertex. So from 1 to 2, there is an edge. So that's why I can move the current vertex to vertex number 2. Now the current vertex is vertex number 2. So from vertex number 2, I should not take vertex number 1 and 2 because these are duplicate vertices. So go to vertex number 3. And before actually moving the current vertex from vertex number 2 to 3, check whether there is an edge between vertex number 2 to 3. Vertex number 2 to 3, there is an edge. So now move the current vertex from vertex number 2 to 3. Now the current vertex is vertex number 3. So from vertex number 3, I should not take 1, 2, or 3 because they are duplicate vertices. Now select vertex number 4 as the next vertex and check whether there is an edge between vertex number 3 to 4. Vertex number 3 to 4, there is an edge. So move the current vertex to vertex number 4. And finally, this is 4. And finally, move from vertex number 4. We cannot select vertices 1, 2, 3, and 4 because they are duplicate. Now select vertex number 5, which is not duplicate, and check whether there is an edge between vertex number 4 to 5. Vertex number 4 to 5, there is an edge. So now the current location, I may assume vertex number 5. Now I have reached all of the vertices from starting from vertex 1 to vertex 5. And finally, we need to check the third step. There must be an edge between the last and the first vertex. So that is from 5 to 1. From 5 to 1, there is an edge. So now the solution has arrived and a Hamiltonian cycle has been formed. So this is one of the solution. The first solution we got is 1, 2, 3, 4, and 5. And as usual, from 5 to 1. A Hamiltonian cycle has been formed. Now, let us see whether there is one more solution to solve this particular problem. So, Initially I have started from vertex number 1 and selected vertex number 2, and assume that I am not selecting vertex number 2, however I am selecting vertex number 3. So is it possible? Check whether rule is applied or not. The next vertex must not be a duplicate. 3 is not a duplicate vertex, and there must be an edge between current and the next vertex. Current vertex is 1 and the next vertex is 3, and there is an edge between current vertex to next vertex. So I can move the current vertex number to 3. So once I reach it to 3, now I shall take the remaining vertices. The remaining vertices are 2, 4 and 5. So let me consider vertex number 2. From 3 to 2 I am moving, and check to see that whether there is an edge between 3 and 2. From 3 to 2 there is an edge, so I can move to 2. So once I reach to vertex number 2, now I shall take either vertex number 4 or vertex number 5, because 1, 3, 2 are duplicates. So let me assume that I am moving to vertex number 4. From 2 to 4, check whether from 2 to 4 there is an edge or not. Yes, there is an edge, so I can move to the vertex number 4. Finally, from I can move from vertex number 4 to vertex number 5, so which is accepted, because there is an edge between 4 to 5. 4 to 5 there is an edge, and as we already know, there is an edge from 5 to 1. Another Hamiltonian cycle has been formed. So what is the second solution? Xi is equal to 1, 3, 2, 4, 5, and from 5 to 1. Okay, so this is the second solution we got. And similarly, let me try the third solution. So I am starting from vertex number 1, and from vertex number 1 I move to vertex number 2, which is a valid vertex. There is an edge from 1 to 2 available. Next, now instead of moving from 2 to 3, I am moving from 2 to 5. 2 to 5. So now check whether there is an edge between 2 to 5. 2 to 5, yes, there is an edge, so it is a valid move. Now the current location will be 5. Now from 5 I shall move either to 3 or 4. Now I am moving to vertex number 4. Vertex number 4 from 5 to 4. Check whether there is an edge or not. From 5 to 4 there is an edge, so I can move. Now the current location will be 4, and then I shall move from 4 to 3. Check whether there is an edge from between 4 and 3. Yes, there is an edge, so I can move. Finally, from 3 to 1. 3 to 1 there is an edge, so I can form a cycle. So what is the third solution? Xi equal to 1 to 2, 2 to 5, 5 to 4, 4 to 3, and 3 to 1. See in the graph, 1 to 2, 2 to 5, 5 to 4, 4 to 3, and 3 to 1. Like this I have started from vertex 1 and ended up with vertex 1. So like this there will be multiple solutions. As we know, in case of backtracking there will be multiple solutions possible. So like this we are going to determine all of the Hamiltonian cycles that are available in the given graph, and print the Hamiltonian cycles with the vertex numbers. That's all about Hamiltonian cycles problem using backtracking. Hope you understand the logic. That's all for now.